Now let's see some defects in the long form of periodic table. So the first one is dispute in the position of hydrogen. The problem regarding the position of hydrogen is not settled satisfactorily. In terms of electronic configuration, 1s1, so hydrogen has only one electron, which is in the 1s orbital. So it is to be placed in the alkali metal group. The formation of H plus also supports its placement in the group 1, but it can also form H minus, means so negative charge, so H minus, like the halogens. For example, F minus, Cl minus, Br minus. Similarly, it can also form H minus in some compounds by taking an electron. So thus, it shows a similarity with the halogens to get placed in group 17. But in fact, hydrogen differs significantly from both the alkali metals and halogens. Next defect is the dispute in the position of helium. Again, the position of helium is not settled. In terms of electronic configuration, as helium has only 2 electrons, it goes in 1s. So 1s2 is the electronic configuration. It should be placed in the alkaline earth metal group, that is group 2. But from the standpoint of the chemical inertness, it is placed in the family of inert gases in the group 18, having the general electronic configuration Ns2Np6. So this Ns2Np6 is like for the this is the common configuration for the other inert gases. But in case of helium, it is a little bit exception. There is no Np6, only Ns2, 1s2. Thus, from the consideration of the properties, it is to be placed in the group of the inert gases, while from the electronic configuration, it is to be placed in group 2. But ideally, it is in the group 18. If you see the modern form of the periodic table, helium is placed in the group 18. But still, ambiguity is there. The next one is the borderline elements. The borderline elements lying in the border range of two adjacent blocks, that is S block and B block, or F block and D block, or D block and P block, are having some properties common to both the blocks. Hence, the separation by a sharp line of demarcation cannot be justified in such cases. Next one is the detachment of F block elements from the main periodic table. The inner transition series, that is the F block elements, are thrown out from the main body of the periodic table. It indicates apparently that the members of this series do not obey the trends followed by the main body elements. Next one is the position of isotopes of lighter elements. The isotopes have not got separate rooms. For the heavier elements, the properties of the isotopes of an element are more or less the same. But for the isotopes of the lighter elements, the physical, kinetic, and thermodynamic properties are drastically different. For example, the isotopes of hydrogen, that is hydrogen, deuterium, and tritium, are so different in properties that to place them in a single room is really surprising. But these isotopes, as of now, are considered to be in the same room. Now, position not always determined by electronic configuration. In the d block elements, the missing of the groups having electronic configuration n-1 d4 ns2 and n-1 d9 ns2 do not have any explanation apparently. So if you see the electronic configurations of the d block elements, you cannot find these electronic configurations. The reason actually is half fill full fill concept. So if you see n-1 d4 ns2, here d orbital can accommodate 10 electrons, but it has only 4. And if you see this one, n-1 d9 ns2, d orbital can accommodate 10 electrons, it is one shot, 9. So what it will do, so it will take one electron from here and it will fill the d orbital. So it will become n-1 d10 ns1. Similarly, it will also take one electron from here, it will go here and it will become n-1 d5 ns1. So this is called d orbital is half filled, and here d orbital will become full filled. So this half filled full filled concept also we will learn later. So these two electronic configurations do not have any explanation apparently. Chromium and molybdenum are having the configurations n-1 d5 ns1, as I was saying, half filled. Here d is half filled, while tungsten is having the configuration n-1 d4 ns2. But still tungsten is placed in the group of chromium and molybdenum. So there is some discrepancy. So for example, chromium and molybdenum, they do this half filled and full filled concept, but tungsten is comfortable in having this d4 configuration without feeling its half filled nature, half filled d. So there is some discrepancy in the same group, but still this chromium, molybdenum and tungsten, they are in the same group. In fact, the electronic configurations for the members of 5D series, that is 6 period, differ from their respective congeners of the 3D and 4D series in many cases. But the periodic table does not care for it. This drawback is the reflection of the drawback present in the Aufbau principle. Now, what is this Aufbau principle? That will we discuss in the later videos. Maybe in lecture number 6 or 5. Yeah, it will be discussed in the lecture number 5 or 6. You can go and check. A similar situation arises in the inner transition series also. Thus, it can be safely concluded that the heavier elements are placed in order of their increasing atomic numbers, not in terms of electronic configuration. Yeah, so the take-home message is that this periodic table, or the modern form of periodic table, that has been constructed based on the increasing order of atomic number. Neither increasing order of atomic weight nor by the order of electronic configuration. It has been formulated by only the increasing atomic numbers. That you have to remember. Okay.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.